Welcome back to Advanced Skills Learning. Gen AI prototypes are easy. Production systems are hard. In this series, we focus on the decisions that determine whether your system actually works at scale. Today's topic is about a common RAG bottleneck myth. Your RAG is slow because of vector database. Most teams optimize the wrong component first, and that mistake compounds as systems scale. One of the most common complaints in production RAG systems is this: our system is slow. And almost immediately, teams point to the vector database. They assume retrieval is the bottleneck. They assume search latency is the problem, and they start looking for faster indexing, better embeddings, or a new vector database entirely. This assumption feels intuitive because retrieval is visible, but visibility does not equal impact. But here's the reality. In most real-world systems, the vector database is not the bottleneck. In fact, retrieval is usually one of the fastest parts of the pipeline. We're talking tens of milliseconds in most cases. Meanwhile, the rest of the system quietly consumes far more time. If you measure end-to-end latency, retrieval often disappears compared to downstream processing time. If you actually break down the latency of a RAG system, the picture becomes very clear. The largest chunk of time is almost always spent inside the LLM. Not retrieval, not indexing, the LLM, and more specifically, the number of tokens you send into it and the number of tokens it generates in response. Even small increases in prompt size can significantly increase total response time due to token processing. Here's a quick check. What contributes most to latency in a typical RAG system? A. The vector database. B. LLM generation. C. Embeddings. Keep your guess. The answer is B. LLM generation. Because tokens equal time, the more tokens you send, and the more tokens you ask the model to generate, the slower your system becomes. This is why optimizing token usage is often more impactful than optimizing retrieval speed. And this is where most systems go wrong. The first hidden bottleneck is prompt size. Teams retrieve too many chunks, include redundant information, and build massive prompts. The LLM now has to process all of that context before it even begins generating an answer. Larger prompts don't just increase cost, they directly increase latency. Many systems unintentionally duplicate similar chunks, further inflating prompt size without adding value. The second hidden bottleneck is re-ranking. Cross-encoder re-rankers can significantly improve relevance, but they come at a cost. Each candidate document must be scored, often sequentially, which adds hundreds of milliseconds or more. In many systems, re-ranking is added by default without evaluating whether it is actually necessary. In high-throughput systems, this additional latency can quickly become a major scalability constraint. The third bottleneck is over-retrieval. This is closely tied to prompt size. Teams increase top K values thinking more data will improve answer quality. But what actually happens is the opposite. The model receives more noise, more irrelevant chunks, and more tokens to process. This slows down the system and can even degrade answer accuracy. This creates a double penalty: slower responses and reduced answer clarity due to noise. Let's do another quick check. If your RAG system is slow, what's the best first optimization? A. Increase top K. B. Reduce prompt size. C. Add more re-ranking. Keep your guess. The answer is B. Reduce prompt size. Smaller, more precise context leads to faster inference and often better results. Well-curated context reduces both compute cost and cognitive load on the model. So what should you optimize instead of blaming the vector database? First, improve retrieval quality rather than quantity. Better chunking, better embeddings, and better query understanding reduce the need for large top K values. Second, use context compression techniques to remove redundancy before sending data to the LLM. Third, apply query rewriting so you retrieve exactly what you need instead of everything that might be relevant. These optimizations shift the system from brute force retrieval to precision-driven design. Here are the key takeaways. Latency in RAG systems is not driven by how fast you retrieve data. It is driven by how much data you send to the model and how much the model has to generate. The vector database is rarely the limiting factor. The real bottleneck is your pipeline design. If your system feels slow, don't start by replacing your vector database. Start by measuring where the time actually goes. Look at prompt size, look at token counts, look at re-ranking overhead, because in most cases, the fix is not a faster database. It's a smarter system. The fastest systems are not those that retrieve more, but those that send less to the model. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more Gen AI explainers and practical system design insights. We break down these real-world Gen AI system decisions every week on this channel.